Okay, so we are going to get started with part 2 over here. And in class, we looked at, different graphs that we can use for categorical data, different graphs we can use for numeric variables. We looked at, one variable at a time, two variables compared, even three or four. And as I mentioned in class, depending on the type of variables and the type of variables you want to compare, you're going to have a certain graph. So we're going to look at just a couple displays for the categorical variable. We already discussed in class bar charts versus pie charts. Both of these are used for categorical data. Bar charts, we simply have a bar that correspond to either the number of responses within each category or sometimes the percentage as well. Same thing with the pie charts. One thing to note with a pie chart is that all the data has to add up to 100%. There's no way to have multiple responses, so that's one thing to look out for. Over here we have another data set. We are looking at 40 people who were asked what was their highest level of education. You can see over here we have 2 that completed high school out of the 40, which gives us a percentage of 5%. We had 7 out of the 40 that completed their bachelor's degree, so we had 17.5%. We had 20 with an MBA, that's 50%, 3 with a master's degree, 7.5%, 4 with a law degree, and 4 with a PhD. So this is called a frequency table, or also called a frequency distribution over here. So many times when we look at frequency distributions or frequency tables, oftentimes we are given the frequencies along with the percentages. Frequencies are nice in order to see, how many are in each group, and then the percentages are great when we want to compare different percentages. So it's nice to kind of have the two put together. And then relative frequency is just a percentage frequency as a decimal number. So, but just because we have categorical graphs or categorical data doesn't mean that there's not things to watch out for. So let's look at a couple graphs. And again, the Obamacare enrollment did come up in our activity. So we all saw that. And so the difference is when you first look at this, you're going to say, oh, our goal for, March 31st was 7 million or over 7 million. As of March 27th, which is just, 4 days earlier, we only have 6 million over here. And when we look at that graph at first glance, it seems like we have less than half of what we need, but when we're comparing the numbers a little closer, we'll see that no, we're actually only 1 million away, which is 1/6. And one way to fix this graph is to actually make this with a scale that starts at 0, and now it's going to be much more useful for us to actually compare the two and see that no, yes, there is a difference of 1 million, but the gap is not as big as first noticed, right? This is something called the area principle, which means that we look at the area and our brain automatically compares the area. Same thing with the illustration over on the right, which talks about the shrinking family doctor in California. Again, we have a two-dimensional drawing over here. When we compare that, even if we're comparing a height that's, twice as big, actually what happens when we increase our height and increase our width by 2, we increase our area by 4. So, over here we have 27% in the 1960s. We have 12% in the 1990s. So we're looking at a little less than half. But when we compare the area, we have almost 4 times the area over here. So again, it's the same area principle that's being violated as with our first graph. So just to summarize it again, the two things to watch out for is truncating the axis. This is where we cut off the axis, or maybe don't even have numbers or labeling. We actually don't have that either. Like there's no y-axis with numbers on it. And then oftentimes having a fancy pictograph, it's called, like a fancy picture or illustration, is also another thing to look out for. So oftentimes it's much better just to use a nice bar graph instead, or pie chart.